Okay, here we go with binomial expansion. You remember for homework, we did a plus b squared, and you get a squared plus 2ab plus b squared. When you take a binomial a plus b and raise it to the third power, you get a to the third plus 3a squared b plus 3ab squared plus b to the third. Do you see a pattern? A plus b to the fourth. And notice when we raised to the third, we had a to the third, a to the second, a to the first, no a whatever. So we would expect we're going to start off with a to the fourth. The next term is going to have a to the third. The next one is going to have a to the second. The next one is going to have a to the first, and the last one is not going to have any a at all. Notice up here that there was no b, and we got b to the first, b to the second, b to the third. Same thing's going to happen here, no b in the first one. We're going to get b to the first, b to the second in the next term, b to the third here, and end up with b to the fourth. Now there's also numbers to consider, and I'm going to show you how those come later. But when you raise to the fourth power, you get 1 on the first term, 1. You get a 4 here, a 6 here, a 4 here, and a 1 here. Now notice that 3 and 3 make 6. These are 1. This is a 1 right here that I just marked. 3 and 1 make 4. 1 and 3 make 4. And a plus b to the fifth power, we're going to start off with a to the fifth. 1 and 4 give us a 5 here. Then, of course, we have the a to the fourth. Start off with a to the fifth, now it's a to the fourth. And we bring in that b, the second term. Now that's b to the first. 4 and 1 is 5. The next term, 4 and 6 is 10. The a is going to go down to the third power. The b is going to go from the first power up to the second. Again, notice the two exponents add up to 5. Plus 6 and 4 is 10. A to the second, b to the third, plus 4 and 1 is 5, a to the first, b to the fourth, and lastly the 1 on the end, a there is none, and b goes to the fifth power. Do you see that pattern? Now there's a thing called Pascal's triangle. 1, 1, 1. Third line is 1. 1 and 1 is 2. You can consider that there's like zeros out here in the blank area, before and after. So you'd have 1 and 0 is 1. 0 and 1 is 1, 1 and 2 is 3, 2 and 1 is 3, 1 and 0 is 1, 1, 0 and 1, 1 and 3 is 4, 3 and 3 is 6, 3 and 1 is 4, 1 and 0 is 1. And you see that these coefficients, 1, 2, 1, look up at the very top of the screen, 1, 2, 1. Those are the coefficients when you square. The next line here is 1, 3, 3, 1. Look up here at the second line, 1, 3, 3, 1. Those are the coefficients when you raise to the third power. So if I was going to raise to the seventh power, I'd have to go down to, we'll continue on Pascal's triangle here, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, and 1. And now we get the seventh power. Notice that you're squaring when you get the 2, cubing when you get the 3, fourth power, fifth power, sixth power. So if I was doing a plus b to the seventh, the numbers in front of these terms would be 1, 7, 21, 35, 35, 21, 7, 1. And then this first term would be a to the seventh. The next one would be a to the sixth, and b to the first. The next one would be 21, a to the fifth, b to the second, 35, a to the fourth, b to the third. The a's decrease by an exponent each time, and the b's increase. 35, a to the third, b to the fourth, and once again notice the two exponents in each term. Always add up to 7. This would be 21, a squared, b to the fifth, 7, ab to the sixth, and 1, b to the seventh. Of course, there's a plus sign between each of these. Okay, so hopefully you see that pattern. There you go, Pascal's triangle. Ta-da! Yay! And oh my God, babe, could you come? Your grandson is taking a leak in the hallway. Gotta go, guys. Okay, remember back here when we're raising to the fourth power, Pascal's triangle gives us 1, 4, 6, 4, 1. So let's go back now to the other slide. Okay, I am back and doing basically what we did on the first slide, but I want to show you how this applies if you are trying to raise a binomial like 2x minus 3 to the fourth power. Okay, if we go back for a second, and here we are back again, we know we're going to get a 1, 4, 6, 4, 1. Now remember, these are going to be terms. Oops. So I'm going to put in my plus signs. That one was kind of big because my hand was free in the air. I'm going to erase that because I love to use this eraser guy. There she goes. Whoa, we'll just erase the whole 4. We'll go back to the writing tool and put a plus 4 here. Okay, so there's the numbers from Pascal's triangle. Now besides that, the first term here, the a is a 2x, and b is a negative 3. Okay, you have to look at this as being a plus b. And so remember, the first term is going to give us the a, or 2x to the fourth power. The next term, we're going to have that 2x to the third power. The next one will have the 2x to the second power, then 2x to the first power, and then no 2x at all. And the second term will not appear in the first term, but we will get it once in the next term. Then we'll get the negative 3 to the second power. Then we'll get the negative 3 to the third power. Then we'll get the negative 3 to the fourth power. And there is our complete answer, but it does have to be worked out. This first term, you get 2 to the fourth, 16, x to the fourth. Here we're going to get plus 4 and negative 3 is a negative 12, and the 2x to the third is 8x to the third. The next one we're going to have, this is a 9. Negative 3 squared is 9 times 6 is 54. And 2x squared is 4x squared. And here we're going to have 8x times negative 3 to the third is negative 27. And 3 to the fourth is 81. That'll be a positive 81. So we end up with 16x to the fourth minus 96x to the third. 54 4 times is 216 plus 216x squared. 8 27s, that's 160 and 56. That's a negative 216x plus 81 would be our final answer. End of video. Hope you had a great time.